Hello, 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 and good morning, everybody. Mr. Taco here. Welcome to another wonderful week of math. Happy Monday. I hope you're well. I wore the right shirt today. Look at that. Okay, today, as you can see, there's our topic for the day, comparing fractions on a number line. Number lines can be one of the most useful tools when it comes to fractions because they easily translate from the fractions bars behind me to a number line. Here are the things that you're going to need: math notebook, scratch paper, whiteboard, pencil or whiteboard marker, some sort of ruler or straight edge optional. We are going to be creating number lines today for those of you with whiteboards and notebooks and scratch paper in front of you. So some sort of straight edge to draw straight lines might be helpful, but not required. I'm using the straight part of this protractor today. And then down here are the teaching points. I can accurately place fractions on a number line, and I can use the greater than, less than symbol to compare quantities. Let's get into it. So, to start looking at this idea of fractions, actually I'm going to go to this side today, looking at this idea of fractions in a fractions bar. Reminder, when we're talking about fractions bars, and the entire time we've been talking about fractions bars, the value of this bar is 1. Exactly 1. More than 1, you'd have more stuff over there. Less than 1, you've got less stuff. So it's kind of a built-in number line in and of itself because 0 and 1 are in the same place. We have on top this one divided up into 3 equal pieces, or into thirds. This one down here into 4 equal pieces, equal-ish as I'm looking at that. That one looks a little big, but that's not a problem. This is divided into fourths, okay? And depending on our numerator, we might have 1/3, 2/3, 3/3, 1/4, 2/4, 3/4, 4/4, okay? And how this fits in and how we can use and visually see what fractions are greater or smaller, or greater than or less than one another, is by using these fractions bars. So let's take 1/3, perhaps. We're going to color it in here. Okay? This 1 divided up into 3 pieces, and we have 1 of the pieces, or 1/3. Right? And then down here, we can take 1/4. Okay? 1 divided into 4 equal pieces, and we've got 1 of the pieces, or 1/4. Okay? And you can just see visually which one of the pieces is bigger, which one has more value. Exactly. Our 1/3 up there on the top is a bigger piece. Or we can say that, start some statements here, 1/3 is greater than 1/4. And remember, with our greater than, less than symbol, the mouth wants to eat the larger or greater quantity. Okay? If we added a 2/4, we might say, ta-da. Now we have 2/4. Some of you smart cookies out there will know that that is equivalent to 1/2. Indeed, 2/4 and 1/2 equivalent fractions. So now, which value is bigger? 1/3 or 2/4? You'd be right. 2/4, or excuse me, 1/3 is less than 2/4. Okay, visually we can see it if we have a fraction bar the same size and we shade those values in. We can clearly see which one is greater, right? Same thing if we add a 2/3, right? Now we know 2/3 is greater than 2/4. and so on. If we added a third, fourth, which one would be greater? Yeah, our 3/4 would be greater. Mm-hmm. 2/3 is less than 3/4. If we fill them all in, and we have 3/3 and 4/4. Look at that. They're equal. Why? Because they're equivalent fractions. And not only are they equivalent fractions, but they are equivalents of 1. They both equal 1. Right? So how does this translate then to a number line? Well, I hope you'll notice that I was putting our fractions up here at the top. And these, of course, are 0/3 and 0/4. Right? You ready for the magic? Believe it or not, these fraction bars have been a number line the whole time. Wow, hiding in plain sight. So we can see here, if we imagine this is our number line, yep, just like that, at each spot between 0 and 1, we've divided that space between 0 and 1 into equal parts. And then we can see here, here's a jump of 1/4, another fourth, another fourth, another fourth. Same thing up here with thirds. 1/3, 2/3, 3/3. If we were to put them on the same line, we're going to not do it exactly. We're going to estimate it, but if we go up, fill in our dots here. And this is 1/4. Keeping that same distance, right, that we saw with our fraction bars. And now we can even more clearly see, as we travel from 0 to 1, we're going to hit 1/4 first. Like imagine this is 0 to 1 mile, for instance. You're going to hit a 1/4 mile before you hit a 1/3 of a mile. You're going to hit a 1/3 of a mile before you hit a 1/2 a mile, or 2/4 of a mile. You're going to hit a 1/2 a mile before you hit 2/3 of a mile, and so on. Okay, so really showing, being able to show these fractions as sort of a measure of distance to give us a sense of which one is greater and which one is less than. And we can see it here. So I've got our big number line here. I do want to point out, is this a number line or is this a number line segment? Remember our geometry vocabulary. A line goes infinitely in both directions. So in order for it to be a number line, it's got to have an arrow on one side saying it goes infinitely to the negative, and a zoop arrow over here saying it goes infinitely to the positive. In this case, we are just focusing on the distance between 0 and 1, this particular segment. Okay? If you would like to draw your own number line, these are the parameters for today. You just need the segment between 0 and 1. And if you can see faintly in there, I've got some fraction bars drawn in pencil because I'm going to use them in a second. It would be helpful to have some space above or below. So go ahead and put your number line kind of in the middle of your paper or in the middle of your whiteboard. Okay? Now, because this is such a big number line segment, we should probably put in some landmarks, some kind of common or larger fractions that are going to help us to a little more quickly find our way, right? So let's start with probably the most useful fraction of all, which is 1/2, right in the middle. I pre-counted this because I measured exactly because, you know, I had the squares to do it. There are 30 squares between 0 and 1. So what's half of 30? 30 divided by 2. Well, the 2 tens, or 3, taking our 3 tens, put them into 2 groups. So we've got one group with one set of 10 left over. Half of 10 is 5. So our 1 10 plus our 5 ones is 15. So we'll count 3, 6, 9, 12, 15. And right at the end of our 15th square is going to be 1/2. If you're not doing this on graph paper or something with a grid, that's okay. We can just estimate, and that'll be fine for today. So put it about as close to the middle as you can get it without measuring exactly. Okay? So now we've got 1/2 in here. Are there any other kind of landmark fractions we might want to use? Should we put in thirds? Thirds might be helpful, especially because we have 30 squares between 0 and 1 in our demonstration. So what's 30 divided by 3? Oh, it's 10. That's easy. So let's do that. 3, 6, 9, and then one more makes 10. Go, and then we'll go 3, 6, 9, and one more makes 10. So this would be 1/3, and then this would be 2/3. Okay? Are there any other landmarks or any other big fractions you think would be helpful to have in here before we even get started? Maybe fourths. Yeah. Fourths might work. So what's half of 15? Well, because I know 7 times 2 is 14. And then there's 1 left over. So what do I do with that 1? Can I divide it into 2? You bet I can divide one thing into 2. It's 1/2. So we have 7½ squares for each quarter. 3, 6, 7½. So there's our 1/4. And we'll go backwards. 3, 6, 7½ for our 3/4. Now, why can I go backwards to find 3/4 like that? Because if we're dividing it into equal pieces, right? Dividing it into 4 equal pieces, 4 minus 1 is the same distance away as 0 plus 1, right? So 0/4 plus 1 is going to be 1/4 is going to be 1/4. 4/4 minus 1/4 is going to be 3/4. So we can use that 1/4 distance and go backwards. Again, very, very helpful in this case. So now we have our thirds, our fourths, and our halves. So now, if we start thinking about fractions, and we start thinking about how to compare fractions, we can sort of use these landmarks to help us build our fraction bars on top. Okay? So let's try, what should we try? Let's try something a little smaller. Let's try something with sixths. How many sixths should we use? Let's go with 1/6. Just keep it simple, right? So if we're going to divide this fraction bar into 6 equal pieces, let's start with our half, right? Because we know 6 divides into 2 equally. Okay, so there's our 1/2. And then we want to be able to take that and divide our halves into thirds. So let's go, oh, that's helpful. So we're going to divide this into 6 equal pieces. If it's a little tough to see on the camera, I'm going to put in some, go a little darker here. Okay, so now we've got our fraction bar up top. We're dividing into 6 equal pieces, so we can figure out what 1/6 is. Okay, and I'm thinking about something too, because I'm noticing that 1/6, 2/6 is right at the same spot that 1/3 is. So 2/6 and 1/3 are equivalent fractions. That's helpful to know. That's good information. That also means that 1/6 is going to be half of a third. And that makes sense because 3 times 2 is 6. So here's our sixths. Okay, so we can take a look at 1/6 perhaps is going to be right here, right? Okay. 2/6 I'm noticing lines up or is equivalent to 1/3. 3/6, oh, that's an equivalent to 1/2. Sixths are useful because they've got a lot of equivalents. 4/6, oh, look at that. That lines up with 2/3. And then 5/6 is its own thing up here. Okay. And then on our bottom, let's go with eighths. I think eighths would be helpful. And I'm remembering, right? 4 times 2 is 8. So I bet 2/8 is equivalent to 1/4. Yeah, right? Because I can go 1 times 2 is 2. 4 times 2 is 8. Yeah. So 2/8 I know is going to be right here. So that means 1/8 is going to be half of that. So we have 7.5. It's going to be about right here. Okay. Let's get our other quantities together here. Just kind of, there we go. Okay, and now we'll put our dots in so you can see them a little better. And again, if you don't have a ruler or you don't have grid paper and you're just sort of estimating 8 pieces, that's okay too. Okay, with almost all these fractions, they're not going to be so close that it's going to be tough to see without measuring. So this would be 1/8. 2/8 we see lines up with 1/4. It's equivalent. That means this is 3/8. 4/8, oh, look at that, equivalent to 1/2 and 3/6. That's good to know. Good thing we put 1/2 on our line here. This would be 1, 2, 3, 4, 5/8. 6/8, equivalent to 3/4, and then 7/8. Okay, so are we starting to see the connection between our fraction bar and our number line here? If we were to shade in 1, 2, 3, 4, 5 of our sixths, it would get us to right here where 5 parts are filled in and 1 is not. So that means on our number line, 5/6 is going to live right at the end there. So now we can use this to compare. Let me scoot it closer. Ta-da. So if I asked you which is greater, 3/8 or 2/6? We could look at where they fall in the number line. So we'll find 2/6. We'll find 3/8. Which one is further down the line there? Yep, 3/8 is the greater one. If we had something else like, oh, I don't know, 5/8 or 5/6, right? We'd look here, 5/8 is there, and 5/6 is all the way over here from 0. So 5/6 definitely greater because it's closer to 1. Okay. I think number line stuff is really easiest to envision when we're coming from 0 and really thinking about how far do we have to travel to get to the next thing. Okay, so really knowing 0 here, 1 this way. It's mathematical standard to have 0 on the left and then positive numbers go towards the right. And then if you're going back to the left, it means you're getting smaller in value. Okay? So, I mean, you could, in theory, put 0 over here and 1 over here, but you're not going to see it as often, and people might get confused. All right, let's go to our digital whiteboard and put a few of these on a whiteboard of our own. Okay, so we've got 4 fractions here, and here's our number line. So we've got 3/4, 2/3, 5/6, and 5/8. And we want to figure out which one is greater. Which one is greatest? Which one's second greatest, third greatest, fourth greatest? Okay, let's start with 3/4. Okay, so first we want to find our halfway point. Put my ruler up here. Our halfway point is going to be about right here. Put my ruler away. Here's 1/2. All right, and now for fourths, remember we split our halves into halves. And again, I'm not measuring this one out. I did earlier, but I'm not measuring this one out. Okay, so there's our 4 pieces. And then we go 1, 2, 3. So here's our 3/4 right here. And I'm actually going to turn this dot green because 3/4 is our green fraction. Okay. Now let's go to 2/3. 2/3. And if we look on our, if we were to look back at our back at our number line over here, we can scoot closer. We can see that what helps me too is that 1/3 and that using 1/2 as kind of a guide point for our thirds. So 1/3, it's actually, you know, exactly 2/3 of the way to a half, but it's most of the way to 1/2 without going over it. And then 2/3 is closer to 1/2 than it is to 1. Okay, so let's try that on our whiteboard here. So 1/3 is going to be about right here. And then 2/3 is going to be about right here. And we can confirm that if we were to look back at our number line on the board here, that 3/4 is greater than 2/3. Okay, next one, 5/6. And we want to remind for this one, 6ths are basically taking those thirds and cutting them in half. All right, so our 1/2 would be 3/6. The distance between a third and 0, halfway in between. So that's about 1/6. And then 1/6, 2, 3, 4, and then about halfway in between 2/3 and a whole is going to be our 5/6. Okay, and then the last one, 5/8. Remember 5/8, to get eighths, we cut our fourths in half. So 1/8 is going to be there, just about. 3/8 is going to be there, just about. 1/2, and then halfway between, that's going to be our 5/8. So I'll turn that blue. Okay? Yeah, lots of colors, lots of stuff going on today. If you are feeling struggly, or if you're feeling a little bit lost, come to the small group. I highly encourage it. We do some good work in there. Okay? So, for today, there is an exit ticket. It does ask you to compare some fractions and to use that greater than, less than symbol. Okay, so just as a reminder, come back over here. Our symbol, greater than, wants to eat the bigger amount. Okay, it wants to eat the greater amount. It's pointing towards the lesser amount. Okay, you can use, if you created a number line, you can use it to complete the exit ticket, or there's an interactive number line for fractions that you can use that's linked in the assignment. Okay, you'll see the link there at the top when you click into the assignment. All right, small group starting in just a couple of minutes, so give yourself a little screen break. Come join us in the small group. We're going to be doing some review of equivalent fractions and simplifying fractions, and also talking about our number line stuff. So join us in there. I can't wait to see you. Have a wonderful rest of the morning. You still got PE and science and book club today. Lots to do. All right, you're doing great. You're doing fabulous. You're awesome. I miss you bunches, and I'll see you next time.